We've discussed idempotency before. It's an essential concept for Ansible as well as any other configuration management tools out there. With some exceptions most of the time, Ansible provides idempotent operations, but idempotency is not always something we can achieve by using idempotent modules. This is simply not enough for having an idempotent playbook, and we'll see why in a second. To be idempotent, an operation should check the state. If nothing needs to be changed, then do nothing. This holds true both at the task and playbook levels. Now, let me run our Apache playbook once again, and we'll look at the results together. In our Apache playbook, we're defining a state. When we run it, we can achieve that state with our tasks in the playbook, and also we see a change here. Something has changed. Let's run the playbook once again. Again, we have a change here. We didn't introduce any changes in the playbook, but it's reporting a change every time I run it. Something might be going wrong. Let's see what's going on here. As you see here, the tasks that run yum, copy, line in file modules are all green, meaning they are already at the desired state. Those tasks don't change anything because there is no need to. So those three tasks are fine. I can call the playbook as many times as I want, and they will not make any change because we're already at the desired state. But the last task restarts the service every time I run the playbook and reports a change. Considering the fact that the rest of the playbook doesn't introduce any changes at all, then it shouldn't restart the service, right? There is no need to bounce HTTPD daemon and cause service downtime. But what else could we do, or how can we fix it? Another alternative could be to set the state of that task as reloaded. If I do that, it would be slightly better because instead of a restart which stops and restarts the service, it will then only reload the configuration without bouncing the service. But again, if the other tasks don't introduce any changes, why should I reload the service? Or what happens when a change is introduced by some other task and a restart is required? At the moment, the modules I'm using are idempotent, but the way I use them is breaking idempotency and also at the same time introducing risks, which may even cause downtime. The recommended way to handle such situations is by using handlers. Handlers are the tasks at the end of the play that are triggered by changes made on the managed nodes. If a change has been made by a task, Ansible tracks that and we have the chance to call a handler task that will only run in that case. We can define which task change calls which specific handler task or tasks. Let's see an example and it will be clear. This is a basic task copying a configuration file to a folder. If this operation means a change, the notification at the end of the task will be triggered. So this is an example of restarting a service when the contents of a file change, but only if the file changes. This is again the same task copying a configuration file to a folder. But this time, if this operation means a change, two notifications will be triggered. So a task can trigger more than one notification in case of a need. Handlers are placed at the end of the play. They can only be called by notify actions at the end of tasks. So if I add a notify action to a task, and in case the task introduces any change, the handler is called. If the task doesn't introduce any change, handler will not be called. Which handler is called after which task is entirely up to us. We can even call multiple handlers from a single task like this example. So this is the method playbooks use to recognize and respond to changes introduced at the task level. If all the modules a playbook uses are idempotent, then the playbook itself is likely to be idempotent, but there are no guarantees. We need to design the playbooks with idempotency baked in, and handlers are a great tool that helps us achieve that. If there is no change at the task level, handlers are not triggered. This means the actions depending on the task level changes will not get triggered, and in turn, this helps in making the playbook idempotent. Another critical aspect of handlers is they will only be triggered once, even if notified by multiple different tasks. In this example, multiple tasks indicate that Apache needs to be restarted because they have changed a config file, but Apache will only be bounced once to avoid unnecessary restarts. Let's change the web playbook according to what we've learned in this lecture. So I'll add the handlers section at the end of the play, move this task named restart HTTPD there, and place notifications to call the service restart task upon configuration change. I want to restart the HTTPD daemon after loading the virtual host configuration for my new site. So I'll place a notify action calling the handler named restart HTTPD at the end of the task copying the virtual host configuration. I also want it to be restarted once httpd.conf is changed, so I'll place another notification at the end of that task. If you remember a couple of lectures ago, we installed PHP and wanted to restart Apache after that. So even though Apache has been restarted long ago, I'll still do this because I want to be able to run this playbook on other brand new hosts and still achieve the same result. This is an excellent example of how the order of things we do might impact the resulting playbook. So I'll split this yum task into two tasks, and the one that installs PHP will notify the restart HTTPD handler as well. We also need to pay attention to the name of the handler. It must match exactly with what's called with the notify action statement. Let's run this playbook. You can see here that the handler has not been called and there is no change on the remote machines. As a result, HTTPD service did not bounce. In summary, handlers are lists of tasks, not really any different from regular tasks. They are listed under the handler keyword at the end of the play. They are referenced by a globally unique name and are notified by notifiers. If nothing notifies a handler, it will not run. Regardless of how many tasks notify a handler, it will run only once after all of the tasks complete in a particular play. In the next lecture, we'll continue with further customizations to our Apache playbook.